Welcome to an intro to series and sequences. So we're going to kind of switch gears for a little while from what we've been doing. So let's just jump straight in. What is a series? So a series is essentially an infinite sum We will be focusing on ones that are essentially infinite polynomials. And what I mean by this is that instead of having a highest degree, polynomial, sorry, instead of having a highest degree, it just goes on forever. So the most famous series is probably the power series for e to the x. So the most famous series is the power series expansion for e to the x. Which is e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial, going on forever. And we can write this in summation notation from n equals 0 to infinity of x to the n over n factorial. Essentially, we view this as a limit of a bunch of partial sums that don't go on forever. So this is essentially the limit of the polynomials where we just stop at degree n. So we'll get much more detailed as we go, but series are going to be the driving force for what we're doing. Unfortunately, before we can get to series, we need to get comfortable with sequences. So that will be what we'll be doing sort of next. This section is focusing on sequences, but we will be driving towards series. So how are series useful in calculus? The answer to that is in this class, they will not be particularly useful. So they're actually most useful in the field of differential equations. This is typically the class you take after the intro to differential equations is typically the class you take after Calc 3. So as we learn it in this class, mainly it will be a skill. So in this class, we will learn how to work with series. But we won't do applications with them. Aside from polynomial approximation. Of a function. So essentially, we are coming up with infinite polynomials that match a function. So if we don't give the entire polynomial, if we only give, say, the first 5 terms, the first 10 terms, that will give us a polynomial approximation for a function. Again, the applications get much more exciting in differential equations, particularly as you go further through differential equations beyond the introductory class. For this class, it's mainly just skills-based here, learning how to work with series, learning how to find series, less of the actual applications. In order to work with series, we first have to get comfortable with sequences. And so in our next few videos, we will be specifically looking at sequences. So again, as we move forward, for right now, we're just going to look at sequences. Once we move on from section 8.1, we will get back into working with actual series.